In this chapter, we're going to look at the graphical representations of data. In this lesson, we're going to look at broken line graphs.
Okay, hi everybody. So in this chapter here, we're going to be looking at graphical representations of data. Okay, and so this is stuff that you'd be familiar with here. You see graphs kind of all over the place in advertising, in reports and whatnot. You see a lot of graphs here. But we're just going to take a look at the different kinds of graphs and make sure that it makes sense how to read and get the information out of these graphs here. And in this lesson, we're going to take a look at the broken line graph. Okay, so what a broken line graph is, it's a graph, like it says here, a graph that uses points joined by line segments to display data. Okay, and often, it's used to just show like how a value might change over time, but it can be used to compare all sorts of different things here. So, what are the important parts of the graph? Well, first of all, connecting the points on a graph. So we're going to have these little dots there. Okay, we're going to have points, and we're just going to connect those points there. It's got to have a title. Okay, you need to know what it is that you're seeing in this graph, what the intention is. And then you have to label the horizontal and the vertical axes here. Okay, it's really important that we know what the axes mean. Now, what you need to know when you're making the graph, we need to know what the independent variable is. Okay, and that's the one that's controlled. The independent variable is the one where you choose the value, and we're curious as to what the other variable is going to become based on our choice. Now, in a lot of cases here, time is the independent variable. Okay? Just like I said a couple of seconds ago here when we talk about how something develops or changes over time here, time is usually the thing that we're in control of. The dependent variable is typically the variable that we're interested in monitoring its value. We're curious as to what it becomes. So we're monitoring the one variable, the independent variable, and we're watching what happens to the dependent variable. So, for example, here it says if you are looking at rainfall each month in a country and you cannot guess the exact amount. Okay, so we're looking for rainfall. Rainfall is the dependent variable. It depends on the month. Okay, but there are other things that we could do here. For example, we might look at the growth rate. Okay, you might say like the length. Let's say the length of a baby. Oh, sorry, my handwriting is just terrible here. The length of a baby, that depends on time. Okay, maybe we're looking at how the baby grows every week, sort of thing. I don't know. We could be looking at, for example, the amount of money in your account. Depends on the time of the month. After you get paid and you throw money in, you pay bills and so on and so forth. So we're just interested in how the one variable changes based on the development of the values of the other variable here. So, and on our graph, the independent variable goes on the horizontal axis. Okay, so down here, this is independent, and the dependent variable goes on the vertical axis. Now, let's take a look at an example here of grabbing out some information from a broken line graph. Okay, so in this question, we read, it says the graph below shows the average snowfall in Regina by month. Okay, so here we go. Here's our average snowfall. So in what month was the highest snowfall? Well, we're just going to take a quick look here. Now, bear in mind that the snowfall, the depth of the snow here, depends on the month. So that's what we're seeing here. So down here, this is our independent variable. And over here, the amount of snowfall, this is our dependent variable. Okay, and that makes total sense. I mean, the amount of snow that you're going to get is going to depend on the month of the year. So where is it the highest? Well, here we're just going to take a quick look here, and I can see I got some values at the extremes here, and that's December, and then it wraps around in February and January and whatnot. And it looks like January is pretty high here, but it looks like December is the one that has the deepest snow. Now, how much snow fell that month? Let's take a quick look. So I go up to here, and I'm just going to go straight across here. And I can sort of make out the line there that's going to go all the way across. And it's this mark right here. So it's the one value above the 20. And looking at the scale here, it looks like everything's going up by 1. So it looks like 21 centimeters. That's what we're looking for. Now, during what months is there no snowfall in Regina? Well, okay, it's a pretty fair guess to say, well, there's not going to be any snow in summer. Okay, and we take a look down here, and yeah, we can see where it bottoms out here. It's going to bottom out in June, July, and August. Okay, no snow in June, July, or August, although truth be told, I'd spent some time in Saskatchewan growing up, and I do remember getting snow in August. So, anyway, let's take a quick look here. During what month is the average snowfall approximately twice as much as the average October snowfall? Well, let's take a quick look here. In October, how much did we actually get? Well, here's October. Let's just go across. Follow that line across here. Okay, right here. So that looks like 7. So what we're looking for here, twice as much as 7, it's going to be up at 14. So let's go up to here. What's going to be this one right here? So that's in February. And then let's go all the way across. Oh, we hit another one here in November. Okay, so in February and November, we are getting twice as much as we would expect to see in October. Okay, so in this next question, we read that at the end of every month, Jaden records the price of 2 stocks that she bought. Okay, so here are the 2 stocks, and here's the time, and then the values of the stocks right here. So we're going to monitor the stocks. We're going to come up with the graph here. So that's the first question for this thing right here is graph the 2 stocks for the year in a double broken line graph. Now, by double broken line graph, we simply mean that we're going to have 2 lines shown. And that's just a way of comparing 2 separate bits of information. Now, if you look, you can see that this has already been done before. I had to erase it here and start this again here. It's okay. We'll move through this. So here's our data. So first of all, we need to have a title. So we're going to have the growth of stocks A and B. Now, just like a lot of these problems here, I think it seems pretty clear that the independent variable is going to be time, and in particular the months of the year. So that goes on our x-axis here. So this is going to be time, and it helps to put the units down. We're going to talk about months. And now, and if you can look closely, you can see what I had done before. I just went every 2 here, and I made this January, February, March, April, May, June, July, August, September, October, November, December. So there are our months here. And then over on the y-axis, what we're going to do is we're going to take a look at the value. Notice these are all in dollars here. So I'm going to have this stock value over here in dollars. And I've already played with the scale a little bit. And what we're going to do is I'm going to break the graph here. And so we're going to start, let's say this is going to be, do I have anything here that goes below 1? I don't think we do. Okay, so I'm going to have, let's say, $1, and then $1.25, $1.50, $1.75, $2. Okay, so we're going to go up by 25 cents here. So now I'm just going to jump. We're going to go up to, let's say, $2.50, $3, $3.50, and then up here at $4. I don't think anything exceeds $4. I think that's pretty good. So now, and remember, I put this little mark here to show that I'm breaking the graph. I'm not starting right at 0 there, because there's no need to. And I want you to see this mark here. Oftentimes, you'll see graphs here that will not start at 0, so that they can expand or zoom in on a certain portion of the graph. Now, sometimes that conveys the wrong impression in terms of the material. So that's not always a good idea, but there are other times here, well, no, I want to look very specifically at the growth of the material. If I start maybe the graph at 0, maybe what that does is it zooms back on the material, and I can't quite make out the fine detail. So it's kind of give or take here what you're going to do. Now, in any case here, so we take a look at January, and for January, it looks like stock A and B are both $2.50, so they're both going to start here. But then in February, stock A goes to $2.85. Now, this is going to be $2.75, so $2.85 is going to be a little bit higher. And stock B is going to be $1.25. That's going to be down here. Okay, so stock A, and I'm going to draw a straight line here. Here's stock A. and we'll use A to identify that right now, and then down here B drops right away. Here's stock B. Now, I'm going to build this graph by plotting these values here, up here, one at a time, and then connecting the dots. Now, just so that this video doesn't take forever, I'm going to do that, and then I'll come back and we'll continue on. Okay, and there you go. And so there's the entire graph here. So here's stock A, goes up a little bit, fluctuates a little bit, drops, has a big rise, and then, woo, a big drop right there. Whereas B had a big drop right at the beginning here, and then has slowly worked its way up. It's a little bit of a wobble here, but overall the trend is to go up here. So, use the graph to discuss the trend of each stock and compare them. Well, we really just kind of did that here. So, A, okay, A stayed fairly steady. Okay, then it jumped up and dropped. Whereas B had a big drop initially, had a big initial, whoops, then steadily improved. Now, when you are sitting over here with your stock, it's hard to know what to do. Once you see the whole year, you think, well, maybe sticking with B might be the smarter thing to do. I don't know, because it had a little drop at the beginning, but it's been pretty good from that point on. A, on the other hand, had a big drop, but it all depends. I mean, without actually going through and really looking at this closely, I don't know. Maybe A was even though it dropped over here, still the better one. Maybe the money that she spent, maybe what A did here was enough to kind of keep it above where she was at. Who knows? Because we don't really know where she started with these two stocks. If this is when she bought them or not. So this is just when she started to monitor it. Now, if Jaden were to sell one and buy more of another, which would you suggest and why? Well, you probably need a little bit more information, but you might say A. Okay, you might say A, and why might you say A? Well, if you take a quick look at it, A dropped it, but it went up. It had that potential. It did go up. Now, granted, it dropped, but maybe if you timed it right, okay, if timed right, might make more money. But you might have to really time it here. Now, B, on the other hand, B is showing, whoops, sorry, I was going to write that differently, but anyway, B is showing fairly steady growth. So which one should you choose? Well, it's kind of up to you. Kind of up to you. But we want you to make an intelligent decision. We want you to be able to look at it and pull out information. Even if you kind of reason it through a little bit differently than somebody else, that's okay, as long as you can justify your decision based on the information that you're seeing. Right. Let's take a look at some new information here now. A broken line graph will also help you discover a regular pattern in the data. Okay, so you can look at the data and kind of guess as to how it's behaving, just like we were trying to do with the stock question there a moment ago. It may show an increasing or decreasing trend. Okay, that doesn't mean that it's always increasing or always decreasing, but like on the whole, it's maybe increasing. So for part B, stock B, granted, it had a little drop at the beginning, but on the whole, it was increasing. Whereas A was a little bit more volatile. It had a little bit more fluctuation to it. It stayed kind of steady, that it jumped up and then dropped down. In any case here, when you can identify a trend, that allows you to either interpolate or extrapolate a data value. Now, let's make sure we understand what we mean by those two words there. So when we say interpolate, what we mean here is we're going to estimate a value between two that should say between two known values. Okay, and I will look for my little, I don't have it as handy on me as I thought. But that should say between two known values. Okay, between. So guessing how much rainfall there was in May, if you know how much there was in April and June, right? So if you watch the line kind of go up, and we connect these two values here, taking a guess at what that value in between is. And that's what the broken line graph allows us to do. Now, it's not perfect. It's just an estimation because, I mean, we don't assume that, for example, the rainfall here follows this nice, beautiful straight line here. But it's a way of figuring that out here. Let's say that you wanted to, let's say, figure out, well, you could do the same thing with how much a stock is worth, okay, on a given date. Maybe you know how much it's worth at the beginning of a quarter, and then you know how much it's worth at the end of the quarter, and you just interpolate what the value is on a given date there. Extrapolation means to estimate a value beyond a known range of values. So going beyond the data that you have and maybe making a prediction as to what it will be at certain a point in time here. In one of the courses that I teach here, a really great example of this. So let's take a look at this. Guessing the population of Edmonton in 2014 if you know the data up to 2013. Okay, so we're in 2013, maybe just guessing what the population would have been in 2014. Another great example that we had here was planet distances. Knowing, let's say, the first 5. So I believe that's how that example went. It was a really good example here where scientists had the list of how far away the planets were from the sun. And so they looked at that data and they made guesses as to how far other planets might be. They were looking for a pattern in there. Now, it turns out interpolation is relatively trustworthy. Okay, relatively trustworthy because you're looking at two known values. We're connecting the dots. We're assuming kind of a nice relationship, nice smooth relationship between here. But when we're talking about extrapolation, this is a guess. Okay, what we're doing is we're assuming the pattern holds. Oops, the pattern holds. Now, it doesn't always hold though. Okay, the patterns that we create aren't always the right pattern, and that was why this was such a good example here. When we're looking at the further out planets like beyond Saturn, the pattern worked really well for the ones that they knew, but the pattern broke apart very, very quickly. By the time we got out to, at that point, Pluto, because at that point they were still believing Pluto was a planet, or at least had categorized it as a planet. The guess for that was, or the estimate for Pluto's distance was way off the mark. Okay, so anyway, extrapolation, it's a bit of a guess. It depends how much data you have and what you know about the data as to whether or not it's really trustworthy. Anyway, let's have a quick look at another example. So this example, we read that our graph here says my stock price for 2017. Okay, and it shows here, we can see the months of the year. This is our independent variable, and the value of the stock is on the y-axis, so that's our dependent variable. So now we're going to estimate here, what was the approximate price of the stock on May 15th? Okay, well, and you can see sort of my work here where I started us off before. So May 15th, roughly in the beginning of May here, so we're going to go up. Okay, we're going to go up, and then we're going to come over. And let's maybe line that up here. So we're looking at, I don't know, roughly about here. So what is that? That looks like it could be around, let's say, $3.75. Now, I don't know that that's true. I don't know that the data necessarily followed this nice straight line between May and June when it dropped there. It's just a guess. Okay, but it feels like a pretty good guess. Okay. What was the price of the stock? Oh, sorry, when was the price of the stock above $5? Let's take a quick look here. Where's my $5 mark? Here's $5. Right here. So where did that happen? It happened here and here, here to here, and then from here on. Okay. So, taking a quick look at that, that looks like end of March. End of March to beginning of April. Oops, you can't, I'm sorry. You can't see what I'm writing here. End of March to the beginning of April. Then, what was it here? It was like middle of June. Okay. Middle of June to the middle of August. And then we've got another one here. And again, it jumped up past 5. Where was that? Right about here. And so that was about mid-October onward. At mid-October onward, it seems to go above $5 here. Now, how much did the stock go up over the course of the year? So let's just take a quick look. Well, where did it start? At January here, it started at $1.50. And granted, it had a big rise here, but it dropped back down. So by the end of the year, it's up to here to $6.50. So $6.50, but we have to subtract that starting value here, $1.50. So the answer is it had a rise, an overall rise of $5. Okay? Now, here we go. Predict what price the stock will be at in March 2018. And that's, you can sort of see my work here. I've erased it here. But the idea is that what we would do here is we would take and extend that line, because there's my trend line. That dark line here kind of gives me a sense of the trend. It's the middle of the data. It's what we might call the line of best fit. We do it to try to make sure that we've balanced out the same number of values above the line as below, kind of eyeballing it through the middle here. And now let's take a look at where the months would be here. So based on the width here, what do we got here? This is... Yeah, so let's go out here. So there's January, February, March. So we're somewhere out here. Let's slide that up. Yoink. And I know it's hard to kind of bring that right over here, but we're looking at roughly $7. I don't know that for sure. That's a total guess. It's a total guess that this is going to keep going on here. I don't know that this is the best line of best fit for this data beyond what I'm seeing right here. There, it's great, but I don't know over here. But that's essentially what we're doing. We're making a guess. I feel fairly good about what's going on here. So as long as I don't guess too far out in the future, I feel pretty good about that extrapolation. Okay, now let's just take a moment here and talk a little bit about working with misleading graphs. Sometimes when information is presented graphically, the intention is to confuse the person who's reading it. And they can do that even while at the same time presenting material that is completely true, totally accurate, but presented in a way that communicates something or influences the person reading it to make the wrong conclusion. So because graphs are a visual representation of data, the scale and size of the graph can influence the way you interpret the data. People know that, right? There are common ways that graphs are manipulated to achieve the desired results. One is changing the scale, and I already kind of talked to you about that, where sometimes we'll draw, we'll break the line, we'll break the axis here, so that we don't have to start at 0. We can start someplace else here. Now, sometimes when we zoom in on a part of the graph, that's to add clarity to the reading of the material. Sometimes, though, that's meant to exaggerate what's actually happening here. It might be that the fluctuation is quite small and almost insignificant, but if you zoom in on it enough, that change in the scale makes it look like it's a lot larger. Okay, changing the axis start point. Okay, we were just talking about that. Changing the size of the graph overall. Changing the type of graph, maybe from a line graph to a bar graph. Sometimes when the height, how high up a bar goes, is important. That's where you're reading the material. Sometimes people will adjust the width of the bar because the width also communicates some information to people, or even if that's not where the specific information is coming from, that still influences the way people read the graph there. Anyway, so while the graph may still be technically correct, That's what I was getting at. The message that it displayed can, to the viewer can change their perception of the data. It's very easy to do that with people, to say the right thing but lead them towards an improper conclusion. So let's take a look at this question here. It says, consider the two graphs below that show the percentage of the population of Alberta living in rural areas. Okay, so here's percentage of Alberta population living in rural areas from 1901 to 2001. Percentage of Alberta population living in rural areas from 1901 to 2001. Now, if you look at the y-axis here, it's in terms of percentage, so the scale is exactly the same. But the x-axis is a little bit different here. So we're still doing years, but notice that there are more years shown here. In other words, what we've done here is we've collapsed this one and kind of zoomed in on this one here. So which graph makes it appear that the decrease was more rapid? Okay, well here let's label this A and we'll label this B. A. Okay, and why does it do that? How does it do that here? Well, what it's done here is each line is a larger step in time. Okay, from each line here, when I go from this line to this line, that's a jump of 20 years, 20 years, 20 years. But here, these are jumps of 10 years. So we've got twice as much going on between these two lines as we do between these two lines. And so when we see that drop from here to here, that looks more dramatic than it does over here. Okay, the drop, even though the drop is the same. Okay, from here to here, that's this point, or actually, sorry, no, that's probably fine here. From that point to, actually, that's going to be this, yeah, this point right here. This looks like it's dropped faster, but only because we've kind of collapsed the time frame here, the scale. Which graph do you think is a more accurate representation of the actual change in the rural population and why? Now, that's an interesting question. Which one is more accurate? Well, they're both equally accurate in terms of the information that they're giving. There's no untruthful or dishonest information being given here. Okay, so this question here is really just about a conversation that we would have in class. Which of these two things do you think is giving the information more honestly? Well, they're both, okay, they're both equally accurate. Okay. I guess it just depends on what you're trying to look to grab out of that. Okay. That's a tough question. It's a really, really tough question because there's no dishonest information going on here. You might say though that B, okay, gives more information. Okay, it gives more information or more detail, and maybe that's what you need. Maybe you need more detail about like smaller time chunks here. But if maybe you don't, maybe you just want an overall trend. I just want to know if it's going up or down, right? And then that's what you would do here. Again, kind of a tough question there, but it's a good conversation to have in class. So use the graphs to interpolate what percentage of the population was rural in 1916. Okay, let's go back up here. 1916. So 1916, okay, is going to be, this is 1901, 1921. It's going to be about the halfway point, just a little bit beyond there. Whoops, and we're going to go up. And, boy, what do we got here? That is little under, let's say, for example, let's say from the first graph here, we're getting from A, looks like maybe we're getting like 67%. Okay? Now let's take a look at the second graph here. So 1901, 1911, so that's going to be about halfway in between here. Go up. Okay. So now we come across here, that looks like it's just a little bit over 60. So from B, that's looking much closer to like, let's say 62%. Now, I suspect this one right here is more close to the actual value than this one, because this graph right here is giving us a little bit finer detail about what's happening. So in that sense, if you want to think of it this way, you might think of B as being, again, the more accurate graph. Okay, just because I can do interpolation maybe a little bit easier with this one, because it's not quite as big a jump as you're seeing over here. Now, use the graphs to extrapolate what percentage of the data will be rural in 2011. Okay, well, 2011 would be over here. That's hard to say. I mean, I'm assuming that the graph's just going to keep going down to here. Okay, if I draw sort of a rough trend on this, we've got here 1, 2, 3, 4, 5, 6. So let's get like 3 and 3. So let's try that, roughly speaking. Yoink. Well, now that's way down there, so that's not great. But that looks like, what have I got here? About 5%, it looks like. So from A, let's say that's down to about 5%. Or no, that's a little bit, that's about 10% actually. Closer to 10, maybe a little bit lower. Here, again, 2011 is going to be somewhere over here actually. Is that right? No, these are going up by 10, so this is going to be about right there. So now, when I draw my line, and maybe a little bit more data there. There we go. And it's looking about, when I look at that graph there again, it's looking like about 10% for both of them. Okay, but they are both talking about the same data, so it's the same general shape, even though there's a little bit more detail coming out of that one. Anyway, there's not always an exact right or wrong to these questions, but you're going to get in the ballpark. It helps you understand the data to get a sense of what's going on so that you can make some fairly informed decisions.